So Bronsted acid and Lewis acid. So how do you understand that which one is a better acid and which one is not that good? So we see the ionization of an acid. So if ionization of an acid is good, then we say this acid is better. If we see the ionization is not that good, then acid is a weaker acid, right? So a strong acid means that it will ionize 100% in a solution, and a weak acid is something which does not ionize much. All right, so how do you understand which is, and how you figure out of given acids which one will be the good acid? For example, HF, HCl, HBr, HI, and I ask you a question, which one is a better acid? So what you have to do is you have to see the bond length. HF is a smaller bond, HCl is a bigger bond, HBr is another, and HI is the biggest bond. So what do you think? Which bond will break easily? I think your answer will be the longer bond is a weaker bond, it will break easily. So this bond will break easily and this will break very difficult, right? So HI is a better acid than HBr, than HF. HF is a weak acid, this is a weak acid, and all these are strong acids. SA means strong acids, and out of these HI is the best acid because the bond length is more, so H plus is removed very easily, so it gives more H plus. So best acid is HI out of these, and this all these three are strong acids. HF is a weak acid. Next, if we see, if we s- see these these were in a group, hydrates of elements in a group. If you go down the group, the bond length is increasing, so acidic character is increasing. All right, remember this. And if you are seeing in a period, we see through electronegativity. More the electronegativity, more will be the acidic character. For example, if I compare CH4 and take ammonia, we take water and HF. So if you see, electronegativity of element is increasing in this direction, electronegativity is increasing in this direction, so do the acidic character. Electronegativity is increasing, so is acidic character. So in this case, across the period, watch out for electronegativity. More electronegative element will form more acidic compound. And if you go down the group, then the compound element which is at the bottom will form a more acidic compound. Next is, if you want to see, compare the acidic character, you have to see the degree of dissociation alpha. So if you have acid 1 and acid 2, so you want to have a ratio, then compare degree of dissociation. Strength of acid 1 upon strength of acid 2 can be compared by alpha 1 by alpha 2, or you can take square root of dissociation constant K1 by K2. So this is a formula we have over here. And if you have ionic product of water Kw, then it comes out to be the product of dissociation constant of conjugate acid and dissociation constant of a conjugate base. For conjugate acid base pair, ionic product equals to Kw equals to Ka of conjugate acid into Kb of conjugate base. For example, if we have HCN, then you take Ka for HCN and Kb for Cn minus, and multiply these Ka and Kb, you get ionic product or Kw for water. Similarly, pKw equals to pKa plus pKb. Alright, so few things more if you want to understand over here. Then if I say Bronsted acid and Lewis acid, what do you think? Are they same or different? Bronsted acid is something which gives H plus, right? And Lewis acid is something which accept lone pair. So HCl is a Bronsted acid, but H plus is a Lewis acid. H plus will accept lone pair, then it will form a neutral atom, right? So H plus is a Lewis acid, but HCl is a Bronsted acid. So Bronsted acid and Lewis acid are different, but if you see Bronsted base is something which accept H plus. So this is Bronsted base. And what is Lewis acid? Lewis base? Lewis base is also something which donates lone pair. So Cl minus could be Bronsted base as well as Lewis base, whereas Bronsted acid and Lewis acid not the same, but Bronsted acid, Bronsted base and Lewis base both could be the same. So this is something we need to understand. I hopefully you must have understood by now